STM tip is made of 90% platinum, 10% iridium. It needs to be cut very sharp, which means you need to cut it at an angle and then actually put a stress, a shear on it as you actually cut it. Separating up. Oh, there we go. And then we'll attach it to a pair of tweezers. And then we toss it in here, slide it underneath this little spring, and seat it right where we need to go in there. And there we have it. Oops. Each sample has a specific set of parameters that make the unit run better. The parameters on the left are showing the various, how big of a scan we want, how many data points. The middle one shows the feedback controls. And then on the far right is the actual bias voltage. Positive means it's going from sample to tip. Okay, here's the sample holder right there. It has a magnet right underneath it, and there we are. And then go ahead, we're going to take the sample. This is actually a gold sample. It's on a little disc. It's going to attach via the magnet. And center it, we're good there. Great. Then we slide the whole sample on the sample holder right onto the actual STM unit. Get it fairly close to the tip, but not too close because you don't want to hit the tip. Now, next we place the actual cover. It has a little lens on it that makes it so we can actually see a much more larger tip. Next, on the software, we want to move it mechanically closer to the tip. We're going to hit the advance button. Okay, now we need to get it really close. I'm not going to film all of that part.
How does that look?
Looks pretty good. We can get a little closer. So go ahead and just click it. Just one at a time. I'll tell you when. So keep going. A little more. Keep going. Okay, that's good. Yes. Now that it's very close, now we're going to hit the approach button, and that'll start the piezoelectronics moving it very, very slowly. Down the very bottom, it shows an orange light that indicates that it is not tunneling. If it turns green, that means it actually has gotten close enough within a nanometer to actually start having electrons transfer from the sample, the gold sample. All right. When the approach is done, you're going to have a little box there. You can just click on the X box or OK. It'll let you know that it actually is tunneling current. That little light there will turn from orange to green, and then it starts to scan. Again, the one on the right here is the actual current, which on all the current measurements will let you know whether it's high or low surface, and then on the right is the actual topographic. So this is the actual what the surface looks like. This is our gold sample. And down here we see the actual cross section. Each time it does a scan, it'll show you the cross section of what it looks like. You can see by the bottom that it is very, very flat. There's not a lot of bumps in this guy, even though it appears to be that way. But it has auto scaling that'll make the high surfaces automatically light and the bottom lower surfaces be automatically dark. Okay, once it's been captured, there's our image. We're going to go ahead and do a cross section. We need to click on the analysis tab right there. And then over here, we've got a button that says create cross section. Once we have that, we just draw a line on our plot, and it'll show us a cross section on the far right. So we'll draw the line, and then there's our cross section right there. And it'll give us a rough idea of the scaling here to here. And that shows us, and what I did here is cutting a line, and we're looking straight at it, okay?